Welcome, everyone. High-speed ground transportation has become a defining symbol of national progress and technological sophistication. The term bullet train, once unique to Japan's Shinkansen, now refers broadly to high-speed rail systems that are revolutionizing how people move across nations. As we move deeper into the 21st century, these systems are evolving into even faster, more efficient, and more environmentally conscious technologies. From magnetic levitation to vacuum tube propulsion, the future of land-based mobility is being reshaped at speeds that challenge our expectations of infrastructure and travel. The story began in 1964 when Japan launched its first Shinkansen line between Tokyo and Osaka. Traveling at speeds of over 200 kilometers per hour, it marked the dawn of the high-speed rail era. Since then, many countries have joined the race, each developing systems tailored to their own geographic, economic, and political conditions. France's TGV and Germany's ICE followed in the 1980s and 90s, setting benchmarks for speed, safety, and design. More recently, China has taken the lead, constructing over 40,000 kilometers of high-speed rail lines, connecting hundreds of cities in one of the largest and most advanced rail networks in the world. The Chinese model is notable for its scale, speed of implementation, and integration with other modes of transit, creating a seamless experience for millions of passengers daily. Technological innovation is at the core of modern high-speed transport. One of the most exciting developments is magnetic levitation, or maglev, a system where the train floats slightly above the track using powerful magnets. This eliminates friction and allows for extremely smooth, silent travel at very high speeds. Japan's Shinkansen project, which uses maglev technology, is currently under construction between Tokyo and Nagoya. It is expected to begin partial service later this decade, with trains reaching speeds up to 374 miles per hour. China has also unveiled its own maglev prototype capable of similar speeds, and researchers continue refining both linear motor systems and superconducting magnets to reduce energy consumption and improve reliability. The engineering challenge is immense, as maglev systems require new types of track, advanced cooling systems, and precise control mechanisms to maintain stability at high speeds. Meanwhile, another futuristic concept is gaining traction. Vacuum tube transport, better known as the Hyperloop. Proposed by Elon Musk in 2013, the Hyperloop would send passenger pods through low-pressure tubes at speeds over 600 miles per hour. By dramatically reducing air resistance, it could achieve travel times faster than commercial airliners on short to mid-range routes. Companies such as Virgin Hyperloop, Heart Hyperloop, and Transpod are actively developing prototype systems. In 2020, Virgin Hyperloop completed a manned test ride on a short track in Nevada, showing proof of concept. However, significant engineering, cost, and regulatory barriers remain before commercial deployment becomes feasible. The tubes must be perfectly sealed, vibration must be minimized, and passenger comfort at extreme speeds remains an open challenge. While future technologies are promising, ongoing progress in traditional high-speed rail continues globally. In India, the Mumbai-Ahmedabad corridor is under construction with Japanese cooperation and Shinkansen technology. The project aims to reduce travel time between the two major cities to under 3 hours and will become India's first true high-speed rail line. Construction has already completed over 300 kilometers of viaducts, and service is expected to begin in stages before the end of the decade. Simultaneously, India is building the Namo Bharat regional rail system, which will offer high-speed commuter service between Delhi and Meerut, cutting the journey to under 45 minutes. These projects represent a strategic shift in Indian transport policy, aiming to decongest roads, reduce air pollution, and boost regional connectivity. In Europe, long established as a high-speed rail pioneer, development continues with an emphasis on efficiency and market competition. France and Germany are upgrading lines and rolling stock, while smaller nations like Spain, Italy, and the Netherlands are expanding their own networks. Cross-border services such as Eurostar are facing new competition from startups like Huro and Virgin Group-backed ventures, which aim to provide faster or more customer-focused options for international travelers. Morocco has already launched Africa's first high-speed line between Tangier and Casablanca, with future extensions planned to Marrakesh by 2029. These expansions demonstrate that high-speed rail is no longer confined to Asia and Europe, but is becoming a global priority. Even countries without historical rail cultures are beginning to explore high-speed infrastructure to accommodate rising urbanization and intercity demand. In the United States, high-speed rail has historically struggled due to political gridlock, vast geography, and heavy car and airline infrastructure. But change is underway. Brightline West is under construction, linking Las Vegas to Southern California with electric trains running at 200 miles per hour. The 218-mile route is expected to be operational by 2028 and is designed to compete with short-haul air travel. California's high-speed rail project, intended to connect San Francisco and Los Angeles, remains delayed and over budget, but recent leadership changes have brought renewed focus to completing the Central Valley segment first. Texas Central Railway continues to push for a Houston-Dallas connection using Japanese N700S Shinkansen technology. Legal and funding challenges persist, but private interest in the project has not diminished. Additionally, Amtrak has proposed upgrades to the Northeast Corridor to enable higher speeds and reduce travel times between Boston, New York, and Washington, D.C. Canada is exploring high-speed options as well. Transpod, a company based in Toronto, is working on a hybrid system called the FluxJet, which blends traditional train infrastructure with near-vacuum conditions. The vehicle would travel at over 600 miles per hour in dedicated tubes using linear induction and air suspension. A prototype was unveiled in 2022, and discussions for a full-scale line between Calgary and Edmonton are ongoing. Though it resembles the Hyperloop, Transpod's technology is engineered for faster implementation using partial atmospheric conditions rather than full vacuum, reducing both cost and risk. If successful, it could serve as a model for other mid-density regions seeking faster and cleaner transit options without the extreme costs of maglev or Hyperloop. Environmental and economic impacts are major drivers behind these projects. High-speed rail is significantly more energy efficient than air travel or private cars, particularly on medium-range routes of 200 to 800 kilometers. Trains can carry large numbers of passengers with relatively low per-person emissions, especially when powered by electricity from renewable sources. In addition to reducing pollution output, high-speed rail stimulates regional development, brings new jobs, and revitalizes mid-sized cities. Stations become hubs for transit-oriented development, increasing walkability and reducing urban sprawl. In many cases, cities served by high-speed rail lines experience growth in tourism, business investment, and residential construction, contributing to a more balanced national development model. Despite these benefits, high-speed rail faces serious challenges. Construction costs are high, particularly in countries with stringent property laws or complex topography. Land acquisition and environmental impact assessments can delay projects for years. Political opposition, lack of funding, and competing transportation lobbies also play a role, particularly in countries like the United States, where car and airline industries are deeply entrenched. Even in China, where development is rapid, cost efficiency and passenger demand must be balanced carefully in more remote provinces. Long-term operational funding, rolling stock maintenance, and cybersecurity are also concerns that require continual investment and innovation. Still, the momentum is undeniable. Technological advances are making high-speed transport more feasible than ever. Lightweight materials, energy recovery systems, AI-assisted routing, and real-time diagnostics are reducing costs and increasing safety. Many nations are exploring public-private partnerships, modular construction methods, and standardized parts to accelerate project timelines. Some proposals even envision autonomous train operation or AI-assisted traffic control systems that can optimize flow across entire networks. As innovation continues, it's likely that we will see hybrid systems emerge, combinations of maglev for short corridors, traditional high-speed rail for regional links, and ultra-high-speed vacuum systems for dense intercity travel in the 2030s and beyond. The next 20 years will likely witness a transition from isolated high-speed lines to regional ecosystems. In Asia and Europe, many networks already operate as integrated systems where trains cross borders, cities, and regions seamlessly. In North America and parts of Africa, early projects will lay the groundwork for similar connectivity. As new lines come online and costs stabilize, we may see secondary cities gain fast rail links, reducing pressure on airports and highways. In parallel, ultra-high-speed technologies like maglev and hyperloop will begin niche deployments, likely starting with freight or short shuttle routes before expanding to mainstream passenger service. Ultimately, high-speed ground transport represents more than fast travel. It's about linking economies, decentralizing opportunity, and creating a more efficient model for human movement. In a future shaped by energy constraints and urban congestion, bullet trains and their successors offer a path to efficient, elegant mobility. As nations continue investing in this infrastructure, they are not just building railways, they are building the backbone of tomorrow's connected world. Thank you very much for watching. Please like and subscribe.